Okay, we're going to do lesson 22.3. The first problem we're going to do is problem number 2, but I've got number 3 marked here just because I want you to see this is a misprint. This actually should have been 8x. So if you see this, that's a mistype in your book, okay? But let's go to problem number 2. And it wants us to determine how many real solutions are in this problem. And they want you to use quadratic formula. But I want to first start with, let's go with completing the square and tie this back to graphing, okay? So with completing the square, we talked about, I'm going to move that over, x squared minus x equals -3. And then we have to figure out what this plus is, plus whatever, okay? So that plus whatever is, how do we get that? We take this, which is -1, divide that by 2. Then whatever you get, which in this case is a fraction, you square that, and that becomes plus 1/4, and that's what goes right here. So we have plus 1/4, plus 1/4. We now factor this as a perfect square trinomial, which is going to be x. And we look at that middle term, minus 1/2 squared equals, and then we have to add this up here. -3 plus 1/4 is what? -2 3/4. Now you can change that to an improper fraction if you want to, but it's unnecessary because at this point what we would do is take the square root. Well, that's a negative, and we talked about you cannot take the square root of a negative number. Okay, if we can take the square root of a number, let's just review here, like let's say 5. It's irrational, but how many are there? There's plus, minus. Square root of 0, we said, is just 0. There's only going to be one solution there because there's no plus or minus. But you can't take the square root of a negative number, which means there's no real solution. That's how we looked at it using completing the square. Well, the same is true when you do quadratic formula, okay? So let's look at that using quadratic formula. So I'm using the same problem. I'm going to rewrite it down here. So I have x squared minus x plus 3. When using the quadratic formula, you do want it equal to 0. You identify your a, b, and c, and this was part of the end of your assignment on lesson 22.2. My a here is 1. It's my coefficient on my x squared term. My b here is -1, and my c here is +3. Now in quadratic formula, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Well, this portion right here is where we determine how many solutions it has by going back to what we just said right here. So if you were to do that, you would take square root of b squared, which is -1, minus 4 times a is 1, times c, which is 3. I'll slide this up a little bit. So if we simplify that, we get square root, that's 1. If we multiply all this, that's minus 12. Which is square root of -11, and because that's a negative, you can't take the square root, which means there are no solutions. Now, I know you're probably thinking, why are the numbers different right up here for completing the square and down here for quadratic formula? Well, the reason is because here we had to set it equal to 0, and remember back in completing the square, we do not set it equal to 0. We move that 3 over, so our number values end up being a little different. But just understand it's the same concept. Okay, let's move on. Let's go down to problem number 10. Sorry, not down. So problem number 10, it says solve using the quadratic formula. Now, I didn't underline this one to work, but I'm going to work it just because you don't need to do quadratic formula here. Think about factors of 20 that subtract to give you 1. Well, that's going to be 5 and 4 because this one is positive, the 5's positive, the 4's negative. So I already have my solutions, -5, +4. This is going to lead into the next lesson, 22.4, which is choose a method to solve. So you don't always have to use quadratic formula in this particular lesson. Think about what is the most efficient and best method. Now, for problem number 11, if you are going to do quadratic formula, you must get it all equal to 0, the same way you do for factoring. Factoring, quadratic formula, everything must be equal to 0. So in this case, I've got to move my 4 over and my -x over. So if I do that, I've got 4x squared plus x minus 4 equals 0. Now if I tried to factor, I would multiply 4 times -4 is -16. Factors of -16 or factors of 16 that subtract to give you 1, there aren't any. If you do 1 and 16, they'll subtract to give you 15. 2 and 8 subtract to give you 6. 4 and 4 subtract to give you 0. So this one is not factorable. So in this case, I do want to use quadratic formula. So again, I go through the process of identifying my values. A is 4, B is 1, C is -4. So now we use the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And I know in the video lesson you hear me sing and stuff, and that's what we would have done in class had we been present here. All right, so let's substitute our values in. So x equals, now anytime you substitute something in, always put it in parentheses. Plus or minus the square root of b squared minus 4a is 4. C is -4 all over 2 times A is 4. Now it's a matter of simplifying. Before you do anything else, just deal with this part first. Make sure it's going to have solutions. Okay? So if I simplify that, and what you can do is on your calculator, just type all that's under the square root in your calculator. So you could do this on your calculator. 1 squared minus 4 times -4. Type it in exactly like that in your calculator to get your value. But when you do that, you're going to get 65. Okay, so you've got -1 plus or minus square root of 65 all over 8. Now, this has two real solutions because 65 is a positive number. Can you simplify 65? And the answer is no. 65 is 5 times 13. And those are both prime numbers. So you can't simplify square root of 65. There's not a perfect square. So what are my two solutions? Okay, you're just going to write them down independently. -1 plus square root of 65 all over 8. And then -1 minus square root of 65 all over 8. Now, if you were doing, and again, these are called exact or radical answers. Okay, exact or radical. Sorry about the bell. If I was trying to do this with approximation, so if the directions had said approximate the answer, okay? It doesn't say that, it says leave in radical form, but if it had said approximate the answer, I would have just done this using the calculator and done my rounding. Okay, so again, most efficient method that you can find. All right, let's go to problem number 17. Back to the previous page. It says, use the discriminant to determine the number of real solutions for the equation. Find the solutions and check and see if they make sense in the context of the problem. It says a scientist growing bacteria in a lab for study. One particular type of bacteria grows at a rate of given formula. A different bacteria grows at a rate of another. In both of these equations, y is the number of bacteria after 10 minutes. When is there an equal number of both types of bacteria? Now, for these particular, well, because these are word problems, they're going to have you round the answers here. So here's what we end up with. What we're wanting is when there are equal number of both types. So what I want is I want this equal to this. So I have 2t squared plus 3t plus 500 equals 3t squared plus t plus 300. Now, if it wanted my answer in radical form, I would do completing the quadratic formula. But because they just want it rounded, all I'm going to do here is I'm just going to use the calculator. Now, there's one of two things you can do. You can either do this as y1 and this is y2 and find where those intersect. I'm going to change mine up a little bit. I'm going to go ahead and get it all set equal to 0. So what I'm going to do is I'm going to move that over here, that over here, and that over here. So that's going to give me 0. I subtract the 2t squared, so that'll give me t squared. Subtract the 3t, that's going to give me negative 2t. Subtract the 500, that's going to give me negative 200. And what I'm going to do is I'm going to set that as my y1. This is my y2. Go to your calculator, find where they intersect. Now, the thing about this is t, again, is time. Time cannot be negative. So when you set up your window, you want to think about your window being set up appropriately. So t here is x. So I want my x min to be 0. I'm probably going to expand my x max, not knowing when the time is that these will be equal. So instead of just going to 10, I might go to something like 30. Okay, this is talking about bacteria growing. That means it's going up. So again, my y min, I'm going to set it 0. My y max, okay, actually, I would y min is 0 is fine because that's what you want it equal to. Okay, y max, you don't need to go more than 10. That's fine. If you want to actually see your horizontal line, what you may want to do is change that y min to something like negative 2, just so you can visually see it on the calculator. Then go to, again, second trace, intersect, and then again, you want just the positive answer, so it should find that for you, and you round your answer here, however the homework asks you to. So hopefully this has been a good somewhat review, help you on the calculator as well, and understand what method you should be using, but make sure you do know quadratic formula.